Hello my dear students, this is Akash SD and welcome to the ASD Physics classes. Hope so you are doing really great. So students, in this video, first we are going to learn about the angle between the vectors concept, how to identify the angle between the vectors and the methods related to them. After that, we are going to see triangle law of vector addition, parallelogram law of vector addition, and how both these laws are similar to each other in the calculation and how these laws are different in terms of drawings. Okay, and after that we will see one or two questions also to how to apply these laws. Okay students, so let's first start the class with learning the angle between the vectors. So students, you can see very well, as I have told you, what is the thing, the concept of angle between the vectors. So see here students, first one, what is there? Head to tail method. We will learn all these things, head to tail method, tail to tail method, head to head method, all these things. Okay, but first I will just take the reference of the two vectors. Let's take here, I have taken the reference of the vectors. I will always draw these two vectors. This is the vector A in this direction and vector B in this direction. Okay, so what is the first one? Head to tail method. That means head and tail of the two vectors will coincide. So students, first I have drawn here the vector A. What is this? This is vector A. And now I will do here what? From the head of the vector A, I will draw the tail of the vector B in this direction. You can see this vector and this vector more or less should be similar here. Okay, so that's why this is called which method? Head to tail method. Head of the vector A is coinciding with the tail of the vector B. Okay, and students, here the angle between vector A and vector B, how to identify here? From the vector A, we will draw here the dotted line here and this angle. Always we have to take which angle? Smaller angle. Smaller angle. Whenever we have to see the angle between the vectors, we have to take the smaller angle. Okay. And here when head and tail is coinciding, from the head of vector A, we have to draw one dotted line, and this angle theta is called what? Angle between vector A and vector B here. Okay. Similarly, after that, if I see tail to tail method, so in tail to tail method, what will be there? Only little bit basic translation of vectors will happen. Translation of the vectors means what? When we are shifting the vectors. What I will do here? This vector B, instead of drawing from here, I will draw from the tail of vector here. That is called the translation of the vectors. Okay, like this here. Now, so what is this? This is the vector B here. Here students, what will happen that here when the tail and tail is coinciding, then say here this is smaller angle. See this side also angle is there, but this is a bigger angle. Okay, but we have to take which angle? Smaller angle. So here angle between vector A and vector will be what? Theta. You draw by any method. What will happen? The value of the angle will not change. So here also let's take 30 degree. Here also it will come 30 degree only here. Okay. So we have seen head to tail method, tail to tail method. After that, next one, let's see here. Now students, this is the head to head method. Head to head method. So in head to head method, what will be there? Let me draw here. Again, this is vector A and here what will coincide? Head and head will coincide here. And see here, this is the vector B here. I have just taken the reference of both these vectors. And here what will happen that? Again which vectors? Again which vectors? Vector A, vector B, and which angle? This smaller angle theta is there. Again, first situation head to tail, if angle 30 degree. Second also it will come 30 degree. Third also it will come how much? 30 degree here. Okay. So again, let me tell you here. When head and tail is coinciding, we have to draw the dotted line and this is the angle theta. When tail and tail is coinciding, no need to draw any dotted line here, directly smaller angle theta here. And when head and head is coinciding, that time also no need of any dotted line here, just directly take the smaller angle theta here. Okay, students? So this is about the concept of angle between the vectors. Three concepts are there. After that, students, if you have understood this thing, let's see this question for the NEET and JEE, very important. See here. Let theta be the angle between vector A and vector B. Which of the following figure correctly represent angle theta? So if you have understood whatever I have taught, you can answer very well here. So see students here, this is vector A, this is vector B here. And here what is there? This tail and tail is coinciding here. What is coinciding? Tail and tail is coinciding. So for tail and tail coincidence, there is no need to do any line here. That means what is there? This diagram is wrong. This is not the angle theta here. This is wrong. Then what is the correct diagram here? Let me draw here. This is vector A and let's take for example, this is vector B. Which angle is smaller angle? Here the correct angle will be this one here. Okay. This should be the correct angle theta. Here the representation is wrong. Okay students. Now next one after that. See here. This diagram here. Diagram B. Here you can see head and head is coinciding and here this theta they have taken a smaller angle. That means anyhow this option is correct here. Now, if you talk about here also what is there? Tail and tail is coinciding. Is there need to draw any dotted line? No, that means this diagram is wrong. That means which diagram is correct now? Let me draw here the correct diagram. Let's take here. This is vector A and this is vector B. This should be the correct angle theta. This is the correct diagram here. Okay, similarly here also. Here what is happening that here head and tail is coinciding. That means here we have to draw the dotted line. That means this one is wrong. Then what is the correct one here? Let's take here, this is vector A and this is vector B. So what is the correct here? Again let me see here. See, this is vector A, they have told. And how is the vector B is coming here? Let me change the color here just to see this one here. This is the vector B. No? Like this is the vector B here. So here head and tail is coinciding. So what I have to do? I have to draw the dotted line here. Okay. And this angle will be theta. This will be the correct diagram here. Okay. So anyhow, if we see the question, anyhow, first option is wrong. This is the correct diagram. Second one, this option is correct only. Here also, this option is wrong. This is the correct diagram. And here also, this option is wrong. And this is the correct diagram. Now, I hope so. The angle between the vectors should be very, very clear. Okay, students, because all these things are needed to become very good in a vectors. That's why we have taken somewhat more time. Now, students, here. Triangle law of vector addition of two vectors. Okay, for more than two vectors, we will see polygon law and all that. But first, triangle law for the two vectors. What is there? Let's see the definition. We have to write in the exam also. What is the definition? See, it states that if two vectors can be represented by the two sides of a triangle taken in same order, then the resultant of these two vectors is represented by the third side of the triangle taken in which order? Taken in opposite order. Now first we have to understand here, triangle we know very well, three sides will be there, but what is the same order? What is the opposite order? Okay, students. So as I have told you very well here, before also, I have done it, but okay, I have taken again. This is the vector A and let's take, this is the vector B as I have taken in the starting also. Now what I wanted, I want to add both these two vectors by the triangle law. So what I will do here, students, here, see please. First I will draw here vector A. This is my water, this is my vector A. Okay, after that, even triangle law, this triangle law is also called which method? This triangle law is also called head to tail method also. Which method? This is called head to tail method also. Now what I will do here, from the head of vector A, I will draw the tail of vector B here. Okay, so see please, this is my vector B is there. Vector B, and you know very well from the angle concept, we know very well this is the angle theta. Angle between vector A and vector B, how much here? Theta. Now how can we identify this vector A and vector B in same order? See please, how they are in the same order. This is the tail, this is the head of the vector A. Again this is the tail, this is the head of vector A. That means vector A and vector B in same order. That means tail, head. That means A and B in which order? Same order. Now what will happen that here, the resultant is represented by the third side of the triangle. In which order? Opposite order. That means what will happen that here, see here. This is the third side of triangle. In which order? Opposite order. Think please. Tail, head. If I am doing tail and head, then it will be same order, just like A and B. But we have to take which order? Opposite order. That means we have to do like this here. Now this is the tail and this is the head. Now you can identify very well. Now this resultant in opposite order. Again I am telling why opposite order. See, tail, head, A and B in same order. But instead of tail and head, what is coming? Head and tail is coming. That means vector R in which order? Vector R in a opposite order. And here students, here please, this vector R is given by vector A plus vector B. This is the resultant here. Okay, vector R equal to how much here? Vector R equal to vector A plus vector B. See here very well. Identify very well what is the same order and what is the opposite order. That is very, very important. Okay, students. So this is the triangle law. This is called which method? Head to tail method. Now, students, see here again. Now, parallelogram law of vector addition. Both the methods will give the same answer, same resultant of magnitude and same direction also, but the drawing is little bit different. Now, see here please. First, let's see the definition. It states that if two vectors can be represented by the two adjacent sides of a parallelogram drawn from a point, then the resultant of these two vectors is represented by the diagonal of the parallelogram drawn from the same point here. Okay, students, so parallelogram you know very well. What will happen that the sides used to be the parallel. Even we can tell square is also one kind of parallelogram is there. Okay, so we can tell all squares are parallelogram, but all parallelograms are not a square. Okay, students, so again I am taking here, let's take here my reference is this one here. Again and again I am taking the reference of this vectors only. This is vector A, and let's take students here, this is vector B. I have taken here reference vectors. We want to add them. Now by which method? We want to add them by a parallelogram method. So what we'll do here? See here, students, see. This is the vector A. And remember that here, this parallelogram method is also called a tail to tail method. Like previous one was head to tail method, this one is what? Tail to tail method. So this is vector A is there. Now what I will do here? From this vector A, I will draw here vector B. Now you can see vector A and vector B, angle is where? Angle is here. Which method is there? Tail to tail method is there. Okay. Now we want to find out the resultant here. Okay. So what I will do here? Let me see here. One dotted line I will draw here, that will be the parallel to vector A, and another one I will draw that is parallel to vector B here, no? As parallel as possible. Okay, now our parallelogram is ready here. Okay, so now what will happen that here, the vectors are starting from here. Okay, that means resultant will pass through the same point, and this will be one of the diagonal. This is what? This is vector R, students. So here also we can tell very well, students, what we can tell? Vector R equal to vector A plus vector B. Okay, this is which method? Parallelogram method is there. Tail to tail method is there. Okay, very well, very easy. Is it, students? Now let's see. Comparison of triangle and parallelogram law. What I told, both these methods will give the same answer, but little bit what is different? So drawing is different. Okay, so let me see here. This side I will do triangle, this side I will do parallelogram is there. Okay, students, so see here. This is vector A I have drawn here. I am going to draw here the triangle method here, head to tail method. So see, this is vector B, and what we can tell very well here, this is the resultant is there. This is the resultant R, and angle between vector A and B how much? As I have told, how much here? This is theta. This is called which method even? This is called, students here, this is called head to tail method. And what is this? This is a triangle law is there. After that, students, now if I draw from the parallelogram point of view, see very well, both comparison we are doing here. This is vector A. Now what I will do here, instead of drawing vector B from the head of the vector A, I will draw vector B from the tail of vector A. That is called what? Translation of the vectors. Okay, this is the vector B is there. Okay, now what is there, students? Angle is where? Angle between vector A and B, how much here? Theta. You can see very well, this is theta, this is also coming theta. Okay, now let's me draw here the parallelogram. Parallelogram here, and let me draw here the resultant. This is the resultant is there. Okay, let me take the color same here. Okay, so see, this is the resultant. Can you see any difference between both of them? Very easy. This is head to tail method, and this is called what, students? Tail to tail method. Here also you can see vector R is going in same direction. Here also vector R is going in a same direction. Only the drawing difference is there, but answer will be same only. Okay, students, very easy. Okay, now after that here, this is triangle law. This is which one? Parallelogram law. But I will just tell you one little bit general scenario. Let's take what is there. Let's take for example here. Here one object is there. Graphical representation. We'll do here. One object is there. Let's take for example, on this object one force is acting in this direction. For the example, now let's take F1 is acting in this direction here. Okay, and what is there? F2 is acting in this direction. F2 is acting in this direction. So you know very well, if only F1 is acting, object will move in this direction. If only F2 is acting, object will move in this direction. But two forces are acting at the same time. Then what will happen that your object will move in this direction? So for that we have to see here the resultant here. That means what will happen that here in this situation? This one. The object will go in this direction, and that will be the resultant force here. Or we can tell here, this resultant force equal to how much? F1 plus F2. Because depending upon the question requirement, sometimes triangle law method is useful, very nice, and sometimes parallelogram method is useful. Okay, so depending upon your intelligence, you have to decide which method you will use to solve the question here. Okay, and here why I have drawn the vector diagram? Because force is which quantity? Vector quantity. We have to draw the vector diagram to calculate its addition. Okay, Now students, after that if I talk about here the magnitude of the resultant, that means this R and this R. Derivation we will do later, no problem. Okay, so here the students, this magnitude of the resultant is given here. We can write here mod R, or we can write here students just like this also, mod A plus B. Okay, or even you can just write R also, no problem. Okay, R magnitude or mod R or mod A plus B. It is given by here. See here, this is given by students. See, A square plus B square plus 2AB cos theta plus 2AB cos theta. Okay, as of now we are going to learn in this class how to use these formulas. Now, so first remember the formula here. Okay students, now after that let's take for example this resultant is making angle alpha from the horizontal. So here alpha, here also how much here? Alpha. So this alpha is given by, remember that here, tan alpha equal to, remember that here, B sin theta by A plus B cos theta vector addition. So these two formulas you should remember that very well. Okay students, so now you have understood all this, very basic. Let's learn how to use this, See this question. A man moves in an open field such that after moving 10 meter on a straight line, he makes a sharp turn of 60 degree to his left. The total displacement just after the start of eighth turn is equal to. When you will think little bit geometry about that, what will happen here, you will see that this shape will come hexagon. Which hexagon will come? Regular hexagon will come. Okay, but okay, I will just tell you here. First, let's see the question here. Starting is that the person is moving in a straight line here. Okay, so let me draw here. See, the person is moving in a straight line here. I will draw somewhat smaller actually so that we can draw completely. Moving in a straight line. After that, what will happen? That here the man was going in this direction, but he will take how much turn? He is taking the 60 degree turn is there. Okay, so 60 degree turn is there like this. 60 degree turn is there. Okay, and let me draw here this one here. See, this vector. This angle how much here? 60 degree. After that, again what will happen that here? Again he will take 60 degree turn here. Again 60 from here. Okay, 60 degree turn. And again he will go there, and again from here 60 degree turn will be there, and again 60 degree turn from here after reaching here. Okay, and he is going here. That means again 60 degree turn is there. Now more or less the diagram will look like this here. Regular hexagon will come, but here I am drawing manually. That means it is not looking that much perfect. So here 60, here also 60. Okay, students, see here also 60 turn is there, 60, and here also 60. And when he is going like this, here also 60. Now let's count how many turns are there. Now in the question they are telling which turn? Eighth turn is there. Okay, so man was, that was the starting point here. Starting point. Which point? Initial point or starting point is there. Okay. So let's see here students. Where is the first turn? First turn is here. First turn. Then second turn. See very well. Third turn. Fourth turn. Fifth turn. Here again. Sixth turn. Again. Seventh turn. And here how much? Eighth turn. In the question what they are asking? After the start of eighth turn, that means from here eighth turn is starting. That means what we have to do is here. This is one vector. This is one vector. This displacement. Now the shortest distance between initial and final point is called displacement, because this is the starting and here they want here. That means this we want resultant here. Okay, students. So you can see very well. If you can see the triangle here, what you can see here, students, see the magnitude of mod A. Let's take for example, I have given you this is mod A and this is mod B. I have just considered. So mod A and mod B is how much? In the question how much given, students? 10 meter. Okay, angle theta how much? Had to tell method how much coming? 60 degree. That means resultant is given by formula. Resultant formula, see here, A square plus B square plus 2AB cos theta. Let's use it here. That means A square means 10 square means 100 plus B square means again 100 plus 2 A into B, that means 10 into 10 100, and which angle? Cos 60 value 1 by 2. So 2 and 2 cancel. After that what this will become here? See 100 how much coming? 300. Or when we will simplify this more here itself, it will become here handle is there, now that will come outside here. So square root of 100 outside means 10. 10 root 3. Value of root 3 how much? 1.732 multiplied with 10. So answer will come how much here? The answer will come 7.32 meter. That means correct answer is here option C.